Hi guys, welcome to the second video on optimization under math studies. In this video we shall continue with basic questions. This time the questions shall include some geometry. I shall solve the 4 questions on the screen in front of you and I shall begin question 1 shortly. So question 1 came in paper 1, November 2015, question 13. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So we are told that there is a rectangular vegetable garden against a wall, and we are going to build a fence around the garden. The total length of the fence is 60 meters and it shall enclose the vegetable garden on 3 sides as shown in the diagram. I'm just reading the wording of the problem. In question A, you are told write down an equation for the total length of the fence, 60 meters, in terms of x and y. So the total length of the fence shall surround the 3 sides of the garden that the question has mentioned, excluding the wall. This is the wall right there, so we're not going to count this. So the 3 sides are this side, which is x meters, this side, which is also x meters, and this side, which is y meters. Hence the total length of the fence is 2x plus y, hence 2x plus y equals 60. In question B, you are told write down the area of the garden in terms of x. So the garden is a rectangle and the area of a rectangle is length times width, which in this case is x times y. So A equals xy. We want to write it in terms of x, so I shall need to eliminate the y right there. And in order to do so, I shall resort to the equation found in A, and I shall isolate the y, and then I shall substitute the expression for y into the original function. So A equals x times y, hence A equals x times 60 minus 2x. I've removed the y and inserted 60 minus 2x, which is the equivalent of y. So this is the expression I have for A. In C, we are told find the maximum area of the garden, and we know that the maximum area is obtained by finding the value of x that makes A dash equals 0. So A maximum occurs when A dash equals 0. Hence, I shall first obtain an expression for A dash by differentiating this function right there. I've rewritten it in black here by expansion. I've distributed the x onto the bracket, obtaining 60x minus 2x squared. Hence, A dash equals 60 minus 4x. Next, I need to equate A dash to 0. So 60 minus 4x equals 0. And I shall solve for x, obtaining x equals 15. I don't want the value of x that makes the area maximum. I want the actual value of the maximum area. So I still need to substitute the value of x that I've obtained into the equation for the area. So 15 times 60 minus 2 times 15. This blue expression right there is simply the same as the green expression, but with 15 instead of x. I've substituted x by 15. Evaluating these numbers using a GDC or whatever, I shall obtain that the maximum area is 450 meters squared. So take a minute to write this down if you will, and I shall begin question 2 shortly. So the second question that we shall tackle came in paper 2, May 2000, question 8, triple I. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So again, we are told that a farmer wishes to enclose a rectangular field using an existing fence for one of the 4 sides. So one of the sides is not included in our calculations. and we want to construct a fence around the other 3 sides. Write an expression in terms of x and y that shows the total length of the new fence. And again, like the previous question, we have x here and another x there and a y here, so the length is 2x plus y. In B, we are told the farmer has enough materials for 2,500 meters of new fence. Show this following equation. So since we already have an expression for the fence, we simply equate this expression to 2,500 because this is the amount of material available, and we isolate the y, obtaining the required expression in the question. Next, in C, we are told A of x represents the area of the field in terms of x. Show the expression for A of x. So the area of the field is x multiplied by y because this is a rectangle, so area is length times width. Hence, instead of the y, I shall substitute the expression I've obtained in B. So it becomes x times 2,500 minus 2x. If we distribute the x over the bracket, we obtain the final expression similar to the one required in the question. In double I, we are required to find a dash of x, which is simply the derivative of a of x. So we differentiate this red expression, obtaining the green expression right there. In triple I, we are told hence or otherwise find the value of x that produces the maximum area of the field. And as we said before, maximum area means that a dash equals 0. Hence, the expression we obtained in the previous question shall be equated to 0. So 2,500 minus 4x equals 0. I solve for x, obtaining this number right there. X equals 625. This is the value of x that makes the area maximum. In the final question in this problem, we are told find the maximum area of the field. So I shall do that by simply plugging the value of x in the original expression for A. So 625 multiplied by this bracket, or you can just multiply in this expression right there. You can substitute the x in either expression. Either way, you're going to get a value of 781,000. This is an approximation to 3 significant figures. So again, in order to find the maximum area, you simply plug the x value into either this expression or that expression, it doesn't matter. And using your GDC, you obtain this exact figure, and then you approximate to 3 significant figures, and this is your final answer right there. So take a minute to copy this down if you will. I shall begin the third question shortly. So the third question that we shall tackle came in paper 2, November 2000, question 8, double I. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So we are told that the perimeter of a rectangle is 24 meters. The table shows some of the possible dimensions of the rectangle. Find the values of A, B, C, D, and E. So, in order to find the value of A, I shall use the equation for the perimeter, which is 2L plus 2W. We know that W equals 10, and the length is equal to A, and the perimeter is equal to 24. Hence, 2a plus 2 times 10 equals 24, and I find the value of a, which is 2. In order to find the value of b, which is the area, I simply multiply the length by the width. So 10 times 2, which is 20, right there. Next, in order to find the value of c, again, I have the length and the perimeter, so I can find the width. So 2 in order to find the length of C, I can simply divide the area by the length, so 27 over 3, which gives me 9. Next, in order to find the value of D, I shall again resort to the equation of the perimeter. I have length equals 4, perimeter equals 24. Hence, the value of D shall be obtained using this equation right there. 2 times 4 plus 2D equals 24. 2L plus 2W equals 24. And we shall simplify and find the value of D. Then finally find the value of E by multiplying the length and the width. So 4 times D, or 4 times 8, gives me 32. So the purpose of this question, question A, is just to give you some numerical examples of how to find the length given the perimeter and the width, or to find the area given the length and the width. These are nice numerical examples that shall serve in B and C when we are trying to carry this out, but in terms of X and Y rather than numbers. So in B we are told if the length of the rectangle is X and the area is A, express A in terms of X only. So let's just assume that the width is Y and the area shall be X times Y, length times width, and the parameter shall be 2x plus 2y equals 24. So similar to these equations, but instead of L and W, we shall use x and y. So I can isolate the y in this red equation right there, obtaining y equals 12 minus x. And then for this value of y, or for this equivalent expression for y, I can simply substitute into the expression for the area. So instead of x times y, I get x times 12 minus x, which is 12x minus x squared. So this is how you obtain an expression for the area in terms of x only rather than in terms of x and y. In C we are told what are the length and the width of the rectangle if the area is to be maximized. So we want to find the values of x and y given that the area is maximum, which we already know means that a dash equals 0. Hence I differentiate the expression for the area. 12x minus x squared becomes 12 minus 2x, and I set this expression to 0 and find the value of x. Then I use the value of x in order to find the value of y using the green equation right there. So since x equals 6, y equals 12 minus 6, which is also 6. Hence, the length and the width are both equal to 6. These are the values that shall maximize the area. So take a minute to look at the answer again and write it down if you will, and I shall begin the fourth question shortly. So the fourth question that I shall tackle in this video came in May 2015, time zone 1, question 15. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. We are told that a cuboid has a rectangular base of width x and length 2x. So there is your width and there is your length. The height of the cuboid is h. The total length of the edges of the cuboid is 72. The volume V of the cuboid can be expressed as such. Find the value of A. So the volume is equal to the length times width times height, which we know to be x and 2x and h. So the volume is equal to 2x squared times h. What we need to do is we need to replace the h with an equivalent expression in x so that the volume is written entirely in terms of x. We are told that the total length of the edges of the cuboid is 72 centimeters. So how many edges does a cuboid have? A cuboid has 12 edges. 4 of them have a length of 2x, and there they are. This is equal to 2x, this right there is equal to 2x, this right there is equal to 2x, and there is an edge at the bottom, but we cannot see it, so at the back of the floor of the cuboid, that is parallel to the 2x, and it is also equal in length to 2x. There are the 4 edges that are equal to 2x. And similarly, we have 4 edges equal to h. There is one of them, there is a second one, there is a third one, and again there is a fourth one that is vertical and inside we cannot see it, equal also to h. That extends from this corner right there vertically downwards. Finally, there are also 4 sides of length x. There is one of them, and there is the other, and there is the third, and then there is the fourth side which begins at this corner and extends into the page, parallel to this side right there. So to summarize, we have 4 sides of length x, 4 sides of length 2x, and 4 sides of length h, and the sum of all of these is equal to 72. Hence, we have an equation in x and h, and we can isolate h, obtaining an expression in terms of x for h. So h is equal to 18 minus 3x. If you want to know how I arrived at this answer, simply I've taken the 4h on one side and 72 minus 12x onto the other side, so I just transferred this 12x to the right hand side, and then I divided everything by 4, and then I split this single fraction into 2 fractions with a common denominator, and I have simplified, obtaining this expression right there. What remains for me to do is to take this expression and insert it instead of this h right there in order to obtain an expression for v that is entirely in terms of x. So 2x squared times 18 minus 3x, and then I distribute and expand and so on, obtaining this expression 36x squared minus 6x cubed. They want an expression in terms of ax squared minus 6x cubed. So the only difference between their expression and mine is that they have an a next to the x squared, and I have a 36 next to the x squared. However, our second term is exactly the same. So in order to find the value of a, I simply just compare it to my number, hence a is equal to 36. In B, I'm required to find the value of x that makes the volume a maximum. And in order for the volume to be maximized, we set v dash to 0. So I just need to differentiate this expression right there, and this gives me the black expression, v dash equals 72x minus 18x squared. I shall then set this equation to 0, and I've done some factorization here. So I have found that x is either equal to 0 or 4. Obviously, x cannot be 0 from physical evidence. We know that there is an actual length, a value of x. It cannot be 0. You cannot have 0 width or 0 length. Hence, the chosen value for x is 4. So take a minute to take another look at the answer and write it down if you will. This concludes our video, and I hope you have found it useful.